Hi Year 10s. Hope you're all well. Miss ya? Well, perhaps not all of ya. So I thought what I'd do today is to do a bit of a lesson from inside my shed. So let's have a quick look inside my shed, shall we? Here you can see, there's a telescope there. There is an engine that I've rebuilt for one of my motorbikes. Here's a ramp. The red thing here is a ramp. And underneath that is all the bits that need to go back on the motorbike when I finally get round to it. There is some mountain bike, some pads at the back there. There's Lucas's old mountain BMX hanging up. What else have we got? We've got my penny farthing. There's a penny farthing there, look. And my unicycle. And my lovely whiteboard. Every good physics teacher loves a whiteboard. And what else do we have up here? Oh, here's my garden. So there we can see the garden. It looks a bit bright in there, doesn't it? Oh, there we go. So there's the garden. A bit of frisbee down there. Some greenhouses at the back and a little seating bit. And out this window you can see a bit more garden. And another bike down there. 2 bikes down there. Okay, so now you know what my shed looks like. So let's carry on. Now this practical is on reflection. Now before 10TS1 start moaning, I know you've already done this practical because we did it in the last week, but I want you to carry it out again anyway, because I mean, what else are we going to do in lockdown? You might as well do some lovely physics, mightn't you? So as I said, this is a dead easy practical. The most important part of this practical is looking at your uncertainties in your measurements. Now we don't mention much on uncertainties, perhaps not as much as we should do at GCSE level. When you stand and do physics at A level, we do lots and lots of work on uncertainties. In fact, our first probably 3 or 4 weeks is all about uncertainties. Okay, so we're going to touch on it a little bit here. Now what you're going to need for this practical is a torch or lamp, or and some way of making it a nice narrow beam of light coming out. You're going to want some A4 paper, you're going to want a protractor, a ruler, a pencil, and I think that's, and a mirror, obviously. Now, I didn't have a mirror with a nice flat edge on it, so I'll show you what I used in a moment. Now, the first thing I want you to do is to get your A4 sheet of paper and draw a line across the middle. So I'll show you what I mean. So you draw a line across the middle, and that's where your mirror is going to be. And to show that this is a mirror, we dash a line underneath it. So that indicates that this is a mirror. And then I want you to put a normal line against the mirror. Now a normal line is one that is perpendicular 90 degrees to that boundary, and we dash this one in. So I'll do that now. When you do this, use a protractor, but I'm just going to guess it. So dash that line in there, label it N for normal, and then we're ready to go. And what you're going to be doing is you're going to shine your light down onto this point here where it hits the mirror. The mirror is going to reflect the light up, and you're going to draw exactly where those rays are, and I'll show you in a minute how we're going to do that. Okay, so watch the rest of the film, watch what I do, and then see the uncertainties in the end. See you later. So this is my experiment setup. I've got my piece of paper with my mirror drawn on and my normal line. I've got a torch, and the torch I've just covered it with a bit of electrical tape to try and get a little narrow beam of light. And to make that even better, I've just got a bit of Lego to make some even smaller little gap inside there. And what I'm going to do is I'm going to shine the light down through here. It is going to hopefully give us a beam of light through this bit and shine down directly onto that point here where the normal is. And because I haven't got a mirror with a nice flat edge that I can put on there, I've got myself a nice knife which has got a real shiny surface on, which hopefully is going to act like a mirror. I'm going to place that along my mirror line, so hopefully I should see a reflected ray coming out of there. So let's have a look, see if it works. Hopefully you can see that really nice beam of light coming down there, striking the boundary where it hits the normal. And what I'm going to do now is I need to mark where it is. So the best way of doing it is to carefully just put some crosses
right in the very centre of that beam, and then I'm going to put my mirror, or in this case my knife, right along there, and hopefully I should be able to see my reflected ray. And there it is, really nice reflected ray there. Now I need to hold this quite still and put some crosses in there in the middle of my reflected ray. Now already, hopefully you can see where the uncertainty is going to lie, because we haven't got a really narrow beam here. It's quite narrow, a few millimetres, but with better equipment, so if I had, say, a laser, I'd be able to get this measurement even better than it is now. So hopefully you can see that, and I'll show you the next thing to do. So we need to, I'll move everything out the way, and now you need a ruler, and with your ruler you're going to draw through that line down to where it struck the normal, and I'm going to make this quite big. I'm going to go through my crosses there all the way up, and I'm going to do exactly the same this side where it went through the normal and through my crosses, which was about there. Draw that line up. Now I'm going to label this 1 and 1. This is where the ray was coming in, so this is known as the incident ray, and this is where the ray was coming out, so that's my reflected ray. The only thing I need to do now is to measure my angles on this. Now, in order to measure that, I didn't have a protractor, so what I've done is I've printed one off online, and I'm going to have to try and use this, so it's a little bit tricky. What I'll probably do is extend my normal line up a bit. So let's extend that normal line up to make it a little bit easier, up to there. Now I can lay my protractor onto that. I measure up to my normal. I can see that is 50, is that right on the centre? Pretty much. That looks to be 50 degrees. So number 1 is 50 degrees, so this angle here is 50 degrees, and let's measure this one. Now we know it should be 50, but let's just have a look to see what it's actually measuring. So we're going to go 10, 20, 30, 40, 50. Oh, I can see that's just over the 50, so I'm going to call that 51 degrees. Now the reason I've labelled these 1 is because I want you to do a few of these, so perhaps about 4, so you could do them all in one go. So if you label each one, it's going to be easy for you to measure those angles, and then you can put your measurements onto a table.
Okay, so here we have my results. As you can see, they weren't too bad, but I have a slight difference here, as the angle of incidence is not the same for everyone as the angle of reflection. So if we take a look at mine, the worst result I've got is, well, that's 1 degree out, that's 3 degrees out, that one's only 2 degrees, and that was the same. So 3 degrees is my worst one. So what I could put is I could put the angle of reflection plus or minus 3 degrees, and obviously that's going to be my uncertainty in this. Okay, so that's how you do an uncertainty for this. You may find that your uncertainty is bigger or worse depending on your setup. As I said, we need that real nice narrow beam, so it's up to you to have a play around with this thing and see how you get on with that. Okay, good luck everyone, stay safe, and I hope to see you all soon. Bye bye.